Today we will do another interesting program from Java, another number related program, that is Krishnamurthy number. So what is a Krishnamurthy number? Let's take an example, 145. Now you see what are its digits. Its digits are 1, 4 and 5. So now what we have to do, we have to find the factorial of each digit. Means the factorial of 1, the factorial of 4 and the factorial of 5. Then we have to sum their factorials. That is, after adding the factorial of 1 with factorial of 4 and with factorial of 5, we need to get this number. If we get the required number, then only we can prove it is a then only we can say that it is a Krishnamurthy number. So let's check. The factorial of 1 is 1. The factorial of 4 is 1 into 2 into 3 into 4. This means 24. The factorial of 5 is 1 into 2 into 3 into 4 into 5 equals 24 into 5 equals 120. So now let's add them. 1 factorial plus 4 factorial plus 5 factorial will be equal to 1 plus 24 plus 120, and this will be equal to 145, which will be our original number. Okay, so just we have to check this. Okay, so let's begin with the program. So let's initialize and declare the class first with its name Krishnamurthy number. Okay, so at the beginning we initialize the class whose name is Krishnamurthy number. Next we will declare a public class with void return type. Next we will declare a public class with void return type, means public void display, and then we will input a number int n, and this number whatever we have inputted, we have to check whether it is a Krishnamurthy number or not. Okay, so this was our initialization process. Next what we will do, this was our declaration process. Now we will initialize some variables to store some values for calculation. Okay, so let's initialize int d equals to 0. As here you can see in this program, from the given number, that is 145, you have to extract its digits. So in this program also we need to perform the digit extraction method, and we have to use the loop for digit extraction. And in order to store the digits, I have initialized a variable int d whose data type is int to be 0. Next we will write int s for sum to be 0, and this int s stands for sum, which will store the sum of the factorials of their digits. So initially we have to find the digits, we have to extract the digits, then we have to find the factorial of those digits. So let me write this for better understanding, that int f will be equals to 1. This is because after you extract the digit from the number, after you extract each digit from this number, you will find the factorial of each digit. So the first step is you have to find the digits, you have to extract the digits. The next step is that you have to find the factorial of those digits. After finding the factorial of those digits, you have to find the sum of those factorials. Then you have to initialize another variable, which will be int s equal to 0, in order to store the sum of those factorials. So this was our initialization process. Next let's start the loop. For int I will be equals to n, I will be greater than 0, I will be divided equals to 10. Next d will be equals to I mod 10. So now see, we are doing the dry run of the program. So your inputted number is 145. By performing this loop, what are you getting? You are separating the digits 1, 4 and 5. How? 145, when you perform modulus division by 10, you will get 5 as the remainder, and which will be your answer of this modulus division, and that is your last digit. So by this you have got the last digit. Next we will keep aside the last digit and do the modular division with the remaining two digits. So here we are getting remainder 4, which is your second last digit or the middle term. So you have thereby separated the middle term as well. And lastly, we will separate the first term, that is 10, 1 modulus 10. So here you will get 0 in the quotient and 0, and ultimately you will get the remainder as 1, which was your first digit to be extracted. So the last digit to be extracted, but the first digit of the number. So in this way you have separated the digits from the number. This is the loop and this is the process for separating the digits. Next, what we will do in this program, if you observe it very carefully, after finding the digits we need to use the loop. After finding the digits we need to use another loop in order to find the factorial of those digits. So we have, whatever we have to do with these digits. So from here you can get a concept of nested loop. That is, one loop, another loop is inside that loop. That is, one loop is inside another loop, inside of another loop. So first we found the digits. Now we have to find the factorial of each digit. Means we have to execute another loop inside this particular loop. Okay. So for int j, I have initialized another variable, and as I am doing the program in for loop, so I can initialize it inside the loop only. Equals to 1, j will be less than equals to d, j plus plus. This is the loop for performing or calculating the factorial of a number. So next, f into equals to d, f into equals to d, and here you end the loop. So this loop is the loop for calculating the factorial of the digit that you have extracted from the number. So this is the loop for extracting the digit from the initializing number, and this is the loop for finding the factorial of the digit that you have found from this number, that you have extracted from this number. So after you find the factorial, what do we have to do? We have to find the sum of the factorial. That is, here we found the factorial 1 factorial 1, 4 factorial 24, 5 factorial 120. So after finding the factorial, we have to find the sum. So we have to find the sum and store it in another variable. These we need to store it in f. These we need to store it in d. And now we have to store the sum of the factorials in another variable, that is s. S will be equals to 1 plus 24 plus 120. Here you will get 145. So now we will write s will be plus equals to f. This means s will be equals to s plus f. This will be a continuing process till the loop runs. So here we end the loop. Now we will write the conditional statement. So if this sum is equals to the number, then we will print system dot out dot println n plus is a Krishnamurthy number else we have to print system dot out dot println n plus is not a Krishnamurthy number, and here we end our program. But still you just observe this thing. The bracket of L started here, ended here. The bracket of public class ended here. The bracket of class ended here. But now we will do the same program using the while loop as we do in every programs. So now we will do the program using while loop. Okay. So let's do it using while loop, and it will be a bit confusion to do using while loop as its syntax is more tough. So now we will write, in order to do the program using while loop, we have to initialize two things earlier. INTI, which will be equals to n for digit extraction, and INTJ, which will be equals to 1 for finding the factorial. Now what we will do, now we will write while I is greater than 0. Now we will find d equals to I mod 10. Inside this we will start another loop. While j will be less than equals to d. Then we will find the factorial f into equals to d. Okay, now we will end this loop, that is j plus plus. Done. Ended this loop. Next what we will do, perform the calculation for sum. S will be plus equals to f, and we will end this loop, that is I divided equals to 10. And here is our loop completed. Just check. 1 2 3 4 5 6 brackets started. 1 2 3 4 5 4 5 6. Okay, 6 brackets ended. Check. Let's check another time. 1 2 3 4 5 6 brackets of starting. 1 2 3 4 5 6 brackets of ending. So this was our program, and this is the way how we did the while loop, and this was our dry run. And in every program I say that dry run is very important for brain mapping. So to do this program you have to always prefer dry run, and it is a bit confusing to do in while loop, but you can try the program in for loop, it will be more easier. So this is the process of doing this Krishnamurthy number. This is the only program where we use the nested loop policy. Okay, thank you.